Hi, so we have a problem from section 6.4 that deals with angular speed and linear speed. So the problem states, when Brett and Will ride the carousel, Brett always selects a horse on the outside row, whereas Will prefers the row closest to the center. The rows are 19 feet 8 inches and 11 feet 5 inches from the center, meaning that Brett is on the row that is 19 feet 8 inches from the center, and Will is on the row that is 11 feet 5 inches from the center. The angular speed of the carousel is approximately 2.6 revolutions per minute, or 2.6 RPMs. What is the difference in miles per hour in the linear speeds of Brett and Will? So just a heads up on this problem, especially with angular speeds and linear speeds, you're going to have to do a lot of conversions, a lot of dimensional analysis. Meaning that you're going to be converting between feet and miles, inches and feet, radians and revolutions, and all that stuff. Okay, so first things first, let's actually look at the formula that we're going to be playing with. So your velocity is your radius times your angular speed, or omega. So V equals R omega. That's the main formula we're going to be using in just a little bit. But before we do that, we have to convert both of the radiuses that we're given, both of the radii, into feet. So we have 19 feet 8 inches for the first one. And that is for Brett's horse. And then on the other one, we have 11 feet 5 inches. And that is Will's horse. So in order for us to convert these guys to feet, okay, we've got to pretty much do 19 feet plus 8 inches times 1 over 12. So basically 1 foot per 12 inches. Okay, let's translate this. 19 feet is approximately 228 inches. Plus 8 inches. Since it's times 1 foot over 12 inches, we can just say divided by 12 inches. Okay? So in other words, 228 plus 8, that gives us 236 inches over 12 inches. Also, too, don't forget your 1 foot. I apologize for that. That foot does not go away. So 236 divided by 12, well, it doesn't go into it evenly. However, both 236 and 12 are both reducible by 3. So that means we can actually convert this into 59 over 4 feet. Okay, we want to keep it as an exact answer as much as possible. Now, for the next one, the 11 feet 5 inches, we do the same exact concept. So 11 feet 5 inches times 1 over 12 feet inches. Okay, so 11 feet is approximately 132 inches plus 5 inches times 1 foot over 12 inches. Okay, so let's clean this up. 132 plus 5, well, that gets us 137. So 137 inches over 12 inches times 1 foot. Well, to kind of clarify what we talked about on the other part, why the inches went away on the last part is because, well, the inches just canceled out. Your units would cancel out. So the only unit we have left now is foot. So we have 137 over 12 feet. Well, 137 over 12 does not reduce. So that's actually where we would stay on that one. So once we converted it to feet, both of the radius to feet, Now we have to convert them into miles because we're trying to figure out the difference in miles per hour in the linear speeds of Brett and Will. So to convert into miles per hour, we have to use the fact that there are 5,280 feet in 1 mile. So we would have 59 over 4 feet times 1 mile per 5,280 feet. Okay. Now, another way to kind of do the dimensional analysis, I've always showed my students using the grid. That's how I've always done it. It makes sense to me. You might have other ways to go about it. That's fine. Now, what this shows here is that the unit feet would cancel out, and all you're left with is miles. So that means now, technically, we have 59 over 4 times 5,280. And the only unit we have left with is miles. So that now becomes, do calculation, $59 over 21,120. All I did was I multiplied 5,280 by 4 on the bottom. And so that would give me 59 divided by... Let me switch calculators there. 59 divided by 21120. So that gives me approximately 0.00279, or I'm just going to say 0.0028 miles. Okay? Now, doing the same exact process for the next one, for the 137 over 12 feet. So, let's see. 137 over 12 feet. 1 mile per 5,280 feet. Okay. So when we cancel out our units, feet cancels out. And now all we're left with is 137 over 12 times 5,280. And then we have our only unit, which is miles. So 137 divided by 12 times 5,280. And that gives us approximately 0.00216 or 22 miles. The reason why I round off at 4 decimal points, that is the engineer's approximation. Okay, so if you're going into a STEM field or an engineering field, it's always safe to just round off at 4 decimal points. Now, we've got the actual radius of the carousel. Okay, we've got the radius of the the horses that they are from the center, okay? So now we have to convert the angular speed from RPMs, which was given in the problem, into radians per hour. This is always a tricky part for a lot of students, okay? Now, the problem gives us an RPM. Let me scroll back up here. The problem gives us a revolutions per minute of 2.6 revolutions per minute. So we need to convert that into radians per hour, because that's how our that's how the angular speed problem works. It's only using radians and radians per hour. So to use or to find omega, which is what we're trying to find now. So your omega in this case is equal to 2.6 RPMs, or revolutions per minute, okay? Now, if you think about it, one revolution, so if you go around something, that means you made one revolution. So in radians, one entire revolution around a circle is considered 2 pi. Okay, if you think about the unit circle, if you go around half of it, you reach 180 degrees, which is pi. If you keep on going and you go back around, that's 2 pi. So you have to multiply this by 2 pi radians per 1 revolution. And then now, since we're having to do it in miles per hour, okay, we have a minute down here at the bottom. Okay, at the very beginning of this omega formula, we have 2.6 revolutions per minute. But the problem says that we need to convert it into miles per hour. So what we need to do is cancel out the minutes, but in order for us to cancel out the minutes, we have to convert it from minutes into hours. In other words, how many minutes are there in 1 hour? Well, there's 60 minutes to 1 hour. Okay, so now we can start canceling out a bunch of stuff. We get to slash and splatter. So the units of revolutions can cancel out, they divide out. The units of minutes can cancel out. So all we're left with now is radians on the top. That's our only unit on the top. And the hour is the only unit left on the bottom. So now we get to do some awesome math. So now omega is equal to 2.6 times 2 pi times 60. And the radians are the only unit left on the top. Over, well, 1 times 1 times 1, well, that just gets us a 1. But the only unit we have on the bottom is hours. All right, so now let's start multiplying. The only thing you want to keep in mind, too, since we are dealing with a radian, we are dealing with angular speed on this one. You want to keep the you want to keep the pi symbol where it's at. You don't want to multiply it by 3.14. So what we're going to do here, we're going to multiply 2.6 times 2 times 60. So that would be 2.6 times 2 times 60. And that gets us 312 pi radians per hour. Okay, that would be our angular speed. Okay, now that we got our angular speed, and we also have the distances of the radius between Will and Brett, now we get to figure out the difference. So, if you remember back from way back when, the difference means you're subtracting. Now, usually you would subtract the largest from the smallest, which, I mean, that makes sense. So what we're going to do, your velocity, well, going back to that formula, velocity is equal to the radius times the angular speed. But since we're trying to find the difference, let me erase that. We're trying to find the difference. So that would be velocity equals the difference in your radius times your angular speed. All right. Now, if we go back to our original problem, let me scroll back up here. The first radius that we had was 0.0028. Okay, so the largest one. 0.0028 minus our second radius, which is 0.0022. Times your angular speed, which is 312 pi radians per hour, or you can just say 312 pi. Okay, pi per hour. All right. So actually what we can do, let's work out the math, because the math is the most important thing. So 0.0028 minus 0.0022, I mean, of course, I'm just basic math, but I don't mind using the calculator, is 0.0006 times 312 pi. All right. Now, since we are converting it into miles per hour, okay, because that's what our final answer should be. That's the units that our final answer should be. You can do 0.0006 times 312 times pi, which now you can put it as 3.14. And that gives us approximately 0.58, let's say 0.59. Now your problem is going to be in miles per hour. That's going to be units. So you can say miles per hour. All right, and that should be your final answer for this particular problem. All right, so basically what we can say is that Brett's linear speed is approximately 0.59 miles per hour greater than Will's. So Brett's speed is approximately 0.59 miles per hour greater, or faster if you like, than Will's speed. Okay? A lot going on in this problem. The only issue is that a lot of people do struggle with what to convert and how to convert. But whenever you're dealing with angular speed, remember your angular speed always has to be in radians per hour, and your radius should always be, in this particular problem, miles. Okay? So as long as you have those two pieces of information down pat, these problems shouldn't be too terribly bad. It's just it's a hard thing for a lot of students to play around with because of the conversions. All right, so as always, throw out those questions, guys. Let me know if you have any more. I don't mind making any more videos. I mean, this is great. This is fantastic. So thank you very much, and until next time, see you guys later.